Hi Evergreen, let's go over Chapter 6, Review Part A. We're going to review for 2 days, so we'll have a review A and B before we have our Chapter 6 test. So let's dig in. Theorem 16, we're going to go over all of our theorems, all of our corollaries, all of our rules, and we are going to just review everything in this chapter so we can be really prepared. So Theorem 16 says, in a plane, 2 points, each equidistant from the endpoints of a line segment, determine the perpendicular bisector of a line segment. Okay, so if you have a line segment and you make a midpoint and bisect this line segment, these two lines are perpendicular. That's what this theorem says. Lines of symmetry in triangles. Equilateral triangles have 3 lines of symmetry because they have 3 equal sides, 3 equal angles. You can cut it down each of the corners and draw a line through the center. Isosceles triangles only have 1 line of symmetry. They have 2 equal angles, and so those 2 equal sides will be on either side of your line of symmetry. Scalene triangles have 0 lines of symmetry because 0 lines are the equal distance or the equal length, and 0 angles are equal as well. Lines of symmetry in a square. Squares have 4 equal sides and they have 4 lines of symmetry. Rectangles have 2 equal sides, top and bottom, left and right, and they have 2 lines of symmetry. A rhombus also has 2 lines of symmetry. Because it's not exactly a right angle, they're not going to be able to fold it in every direction, just from corner to corner. Theorem 17 are equal corresponding angles. So if we have parallel lines in a transversal, each corresponding angle in the same position in relation to the parallel lines in the transversal are equal. Corollary 1. Alternate interior angles mean that lines are parallel. So we have our interior angles because they are inside of the parallel lines. Alternate means they're on opposite sides of the transversal, so x and x and y. These angles are congruent, and if they are congruent, the lines are parallel. Corollary 2, supplementary interior angles on the same side of the transversal mean that lines are parallel. So we have interior angles, and this time they're on the same side instead of alternate, and these are supplementary, meaning they will add to 180 degrees. Corollary 3, this is basically a parallel line with a perpendicular transversal. And so therefore you have 90-degree angles on both corresponding angles. So therefore they are perpendicular parallel lines. Well, perpendicular transversal on parallel lines. Okay, remember to make a construction. We can construct a line parallel to a line given through a given point. So let's watch this video and remember. Okay, let's do our construction number 7 in lesson 3. So this is 6-3. We are going to learn how to draw a parallel line. So the first thing that we're going to do is start off by drawing a line. This is on page 225 in your textbook. So we are going to draw a line. We're going to name it L. I'm going to put some arrows to make it look like a line. Nice. We're going to put a point anywhere we want, but we'll put it there, point P. And we're going to put a line or a point on our line, point O. This is going to be one of our parallel lines. We're going to create our transversal line right now by connecting these points. So this will be our transversal. And our goal is to copy angle O where angle P is so that we can have corresponding angles. So the way we're going to do that is we are going to grab our handy dandy compass and we are going to create an angle. So let's make an angle. Must be kind of small. I don't have much room up here. So this will be our angle right here. And I am going to, oops, I'm going to move this out of the way. I am going to create an arc to find my spot. There it is. On angle O. And then I'm going to put the pointy part of my compass on point P, and I'm going to replicate this angle by drawing the same arc. Okay, now remember how we copy an angle. We are going to measure the distance where the arc touches our angle legs or sides. Matched up perfectly, the best we can. Okay, so see how it's matched with the distance? And so I'm going to take, let's see, if I put my compass here, you can see exactly how I'm going to replicate that. You see how the pointed side is on the line that touches the arc. I'm going to do the same thing up here. There's the line and there's the arc, and I'm going to intersect the first arc. Now I can put a point where those lines are intersecting, and I'm going to draw a line connecting these two points. I will name this line M, and I know that these are parallel lines. Line M is parallel to line L because they have corresponding angles. This is the same measurement as this is. These are corresponding angles. Awesome. That's construction 7. Make sure you do that along with me or right now. Okay, so we have the parallel postulate. Now this is important. This will be on your test. Through a point, not on a line, see how this point is not on a line? There is exactly one line parallel to the given line. So using this point, we can create a line that is parallel to another line. Theorem 18, in a plane, if two lines parallel to a third line are parallel to each other, here we go, 3 lines parallel to each other. Using these corresponding angles to know that it is parallel in correlation to our transversal. Theorem 19, parallel lines form equal corresponding angles, and so we have 1 and 2, same position, 3 and 4, 5, 6, 7, 8, corresponding angles. The angle sum theorem, 3 angles inside of a triangle add to 180 degrees every time, all the time. Adjacent angles of a parallelogram are supplementary. So we have a parallelogram. Basically, we have 2 sets of parallel lines, top and bottom, left and right. And these angles have relationships just like inside of our parallel lines with the transversal. So A and C opposite each other. These are kind of like adjacent angles. They're congruent. B and D are also congruent. And then each side adds, because they're kind of like a linear pair, to 180 degrees. But there are 360 degrees inside of this total parallelogram. Trapezoids are different, especially irregular trapezoids. So they only have one set of parallel lines, top and bottom, and so therefore they only have one relationship that is the same. These linear pairs, top and bottom, will add to 180 degrees. Here we see it again. A and D add to 180, B and C add to 180. And you can imagine this as 2 triangles, if you would like. Corollary 1, if 2 angles of one triangle are equal to 2 angles of another triangle, the third angle is also equal. So basically, if you have 2 triangles where they have A and D congruent and B and F congruent, then you know, therefore, C and F are congruent as well, because there's 180 degrees in a triangle. Corollary 2, the acute angles of a right triangle are complementary. So because there's 180 degrees in a triangle, we have 90 taken from this right angle. So that's 180 minus 90, which is 90. And then it will divide these two to 45, 45. These will always be acute because there is only 90 degrees to be divided between 2 angles in a right triangle. And therefore they are complementary angles and acute angles. Corollary 3, equilateral triangles have equal sides, equal angles, each 60 degrees. 180 divided by 3 is 60 degrees. Theorem 21, exterior angle, remember this is the outside exterior angle from a side extended from the triangle, is found by adding the two remote interior angles. Theorem 22, angle side theorem. So this is two angles that are the same in two triangles, and they have a side that is not in between the angles but opposite the angles that is also congruent, and this means that the two triangles are congruent themselves. Then there's the hypotenuse and leg theorem, which is, we're always dealing with a right triangle in this way. So we have the hypotenuse that is equal to another hypotenuse, and the leg is equal, and we also have a 90-degree angle. So if these things are true, you have two congruent right triangles. Okay, that is it for the day, for the theorems and the corollaries and all these lovely, wonderful things to think about from Euclidean geometry. I hope you have an awesome day. Bye!